All right, everybody. In this video, we're going to be starting section 1.5, part 1. I'm planning on breaking this into 2 parts, so this is just the first part. Again, we're still in the review land. We're talking about combinations of functions today. So today we're just going to talk about your standard add, subtract, multiply, and divide. Where this is going to get a little bit tricky and not that tricky is when we talk about domain. Only on a few. So first of all, we've got 2 functions I gave you. Rewrite the question in another way and simplify. In other words, I'm trying to ask you to figure out what is this really asking. And so there's 2 ways you could see the same question asked. So the notation that you see right here, it's kind of distributive property, but not distributive property in the way that you would think. I'm not saying take function f and function g and multiply it by x. But what I am saying, what this notation does mean, is you are basically saying combine f and g together and it's still a function in terms of x, which again isn't very clear. What does this really mean? This is just telling you to take function f of x and add function g of x. These 2 statements are synonymous with each other. So in a way, we kind of did distributive property, but I'm not multiplying, right? This is function notation. We know that this isn't saying take function f and multiply by x, right? This is f of x. So the same thing is true here. It's saying combine these new things together, f plus g. In fact, you could name that. Hey, let's say f plus g is the function h. Then what does this say? This now says h of x, right? So this is an of x. It's not a times x. Okay, but so what do? We have this question right here. So this is simply telling us to add them together. So I get negative x squared plus 3x minus 2 plus negative x plus 3. The parentheses here are useless. I just wrote it because this plus minus was a little annoying, but really the parentheses, they don't do anything because we're adding, not subtracting. Combine like terms, and I get negative x squared, and then I get 3x minus x is 2x, and negative 2 and positive 3 is 1. So this is f plus g. That's the new name of it, f plus g. Stupid name, but there it is. Instead of calling h of x, right, or j of x, or anything else of x, we're just telling you where it came from, f plus g of x. All right, so the rest of this should be pretty straightforward. F minus g of x is just telling you to find f of x and find g of x and just subtract like terms. So in this case, we have to be a little more careful because when we're subtracting and there's more than one term, we have to make sure to subtract both terms. In other words, we need to make sure that second thing is in parentheses. And distribute, I get plus x minus 3. Let's combine like terms. Negative x squared plus 4x minus 5. And that would be f minus g of x. All right, and then we get to evaluating. So now it's saying f plus g of 0. So there's 2 ways we could approach this. We could build the new function f plus g like we just did and evaluate it at 0, right? So let's do that. So this is just simply saying build your new function, which we've already done. And now let's plug in 0. Which equals 1. But it could also be referred to as find the answer when you plug in 0 to f, find the answer when you plug in 0 to g, and add those results together. So you can do them separately, or you can take the time to build the new function. But either way, it's saying add the outputs of both functions together, either as an entire function or individually. So if I did f of 0, can't quite see the original question here. So I know that f of 0 plug in 0 and I get, we don't need to show our work, I get -2. And I plug in g of 0 and I get 3. And then what are we asked to do? We're asking to add those together. -2 plus 3 is 1. And that's the same answer we got. So you can consider it both ways. Most of the time, we're going to build the new function first and then evaluate that. But you don't have to. So same thing. We've already built the function. So I know the answer is just going to be whatever we get here. 1 squared is 1. It's still negative. Don't make that mistake. It's not a negative being squared. It's just the 1. Plus 4 minus 5 looks like a -2. Or what it could mean, like we did a second ago, which I'm not going to take the time to do, find the answer of f of 1, find the answer of g of 1, subtract them, see what you get. All right. So now let's multiply. I just wrote the functions. I knew I wouldn't be able to see them, so I just wrote the functions and read at the bottom of the screen so I could reference them. So f times g of x is saying exactly what we would think it would mean. Find the function f of x, multiply it by the function g of x. Okay, and so what are we going to get? We're going to simply get, and you can multiply in any order, so I like putting my smaller function in the front. So it's just saying multiply these two things together. And we can always assume we need to simplify even if it doesn't say it. So let's go ahead and do this. I get x cubed. I get negative 3x squared plus 2x. And then I'm going to line them up. So I'm going to get negative 3x squared. Right? 3 times negative x. 3 times 3 is 9x minus 6. And so I get x cubed minus 6x squared plus 11x minus 6. F times g of x equals. And f divided by g is kind of usually a little bit easier to do, honestly, because it's just saying what we'd expect it to mean, which is find function f of x and divide it by function g of x. These two things are synonymous. So then I'm just going to take negative x squared plus 3x minus 2 and divide it by negative x plus 3. Now, simplifying fractions, we know we can cancel out factors. So if we want to go further with this, we would try to factor the top and see if we have any common things that'll factor. I already know that we don't because of this 2 and this 3. This won't have factor that's an x plus 3, so I know we're good. All right. And so now, what does it mean to do f times g of -2? It means one of two things. Either find the new function like we just did and evaluate it, or get f of -2 and do g of -2 and multiply those answers together. Either one, you get the same answer. And honestly, in this case, doing it in this function seems like a real pain in the butt, where doing it individually might be a little bit easier because each of your polynomials is smaller. But either way, it's going to end up being the same thing. So I'll just go ahead and use our new function. -2 cubed, 6 times -2 squared, plus 11 times -2, minus 6. Negative cubed is a negative, so that's 8. That becomes positive 4, so that's minus 24. Minus 22, minus 6. Let's see. We've got negative 30, 54, negative 60. And then this same thing. Evaluate them separately or do it as a new function. So negative, 3 squared. Only the negative's outside, excuse me. plus 3 times 3 minus 2 over negative 3 plus 3, which means the answer is what? Undefined. Because I get 0 in the denominator. And that brings up this consideration of domain that we have to think about when we build new functions, okay? Because if we go back and look at our original functions here in red, there's no issue with plugging in a 3 here. There's no issue with plugging in a 3 here. So there should be no issues. There should be no domain problems. But notice we took two nice little polynomial functions and we put them together in such a way that we built a rational function. We built this rational function. And now, because we did that, we have to think about domain and range. Well, domain. And there being a limited domain. All right. So with that in mind, let's have a little bit more discussion on that. Example number 2. Simplify each expression and include domain restrictions when necessary. Given that f of x is equal 1 over x squared minus 4 and g of x equals the square root of x. Okay. So we've got to be really, really careful here. Let's go ahead and set up our new function. F of x, so this is going to equal 1 over x squared minus 4 all over the square root of x. All right, so let's simplify that out because we don't want to have a fraction within a fraction. So this is really just saying 1 over x squared minus 4 times the reciprocal, so 1 over the square root of x. And so I believe we are sitting here with f divided by g of x equaling 1 over the square root of x times x squared minus 4. So this is going to get a little bit more involved as we move into composition functions in the next lesson. But for now, this is kind of straightforward-ish as long as we remember to think about it. So notice we look at the original function here. The domain of the square root of x, right? So if we just think about that domain, it has to be 0 to infinity. And we look at the domain of this guy, we know x squared minus 4 cannot equal 0, which hopefully we know x cannot equal 2. X cannot equal negative 2. And when we put all that together, looks pretty good, but one thing gets modified. We still can't have a 2 or a negative 2. We still can't be negative, but now we also can't be 0, right? 0 is not a problem here, but as soon as it becomes a denominator, now it can't be 0. So my domain is a little more involved. It's going to be kind of weird. X such that x is an element of, all right, all the things it can be. It can be negative infinity all the way up to, oh, hold on a second. Let's back up. No, it can't, right? So, wasn't thinking, getting tired. This is like my 5th video of the day. So let's think about this. Here, everything but 2 and negative 2. So we can go negative infinity all the way to negative 2. But I can't use negative infinity here. So when I put them together, it's throwing out a lot of stuff I can't use anymore. I can't do negative infinity. In fact, that means, and I can't do 0 anymore. And so my domain is actually easier or shorter than I thought. It's all of the x's such that x belongs to the group 0, still can't use 2, and 2 to infinity. Why didn't I use negative 2? Why is negative 2 not mentioned? Because remember, I can't even use negative 2 because this one says I have to start at 0. right, so it isn't hard, but there's just more things to consider as you're doing the problem. All right, let's do this last one, g of f. Let's flip it around and do it the other way, which could just mean we just flip this over, but I want to make sure. So let's just go from scratch like we haven't done it before. So g, oh, it makes me wonder if I've done something wrong. We'll find out. G is this, and then no, we're good. 1 over x squared minus 4, which I know means I'm going to multiply by the reciprocal. So I should just get g over f of x equals the square root of x times x squared minus 4. All right. I still have all the same domain restrictions, except now 0 is not a problem because I don't have it dividing by 0. I still can't take the square root of any negative, so I can't use any negatives, even though they're fine here. They're not okay here. So now it looks like I'm going to have a very similar answer. My domain are all of the x's that start and this time include 0. Still can't use 2 and go all the way to infinity. Okay, hopefully that makes sense. We're going to go ahead and stop the video here, and we'll see you on part 2.